Kalisha! The board looks like my brain during a pop quiz. What is all this?
Ah, my dear math apprentice. This, my brother, is the before picture of how our minds view algebraic expressions. Today, we're learning how to simplify algebraic expressions, aka turning math messes into math masterpieces.
So, you're telling me we can actually make sense of this?
Oh, yes. By the end of this video, you'll be simplifying expressions faster than all those persons out there that have not yet subscribed to our channel or liking our videos.
You heard that, guys? So, subscribe now and like this video, and let's learn how to simplify algebraic expressions together.
Let's see if they will listen to you. We are now at 235 subscribers. Let us see if we will reach 300 subscribers by the end of April.
You got this, guys! Let's show up, Kalisha.
Haha, let's get right into the video. Before we are able to simplify algebraic expressions, it is very important that we first understand what are like and unlike terms. Let's consider, you have just done your laundry and you're folding your clothes to organise and pack them away. While folding your clothes, how would you organise them?
Well, for me, I would fold and pack my socks together, my shirts together, my shorts together, and my underwears together.
So, you wouldn't just pack any piece of clothing anywhere, right?
Well, on a good day, if the energy is right, I would organize them and put them together based on the clothing category. So, as I said, socks with socks, shirts with shirts, shorts with shorts, and underwears with underwears.
The good thing about all that you've just said is that you know that you should pack the clothes that are alike together.
So, what does that have to do with math?
It's the same exact thing in math.
So, we now have clothes in maths?
Haha, sometimes I really wonder if we are really related.
What is that supposed to mean, Kalisha?
Nothing. Anyways, no, we don't have clothes in math. I was speaking as it regards to the math terms. When simplifying algebraic expressions, we always try to organise and simplify our like terms.
Oh, but it is very easy to look at clothes and know what looks alike and what doesn't. But in math, how would we identify when we have like terms and when we don't?
Like terms are terms that have the same variables and the same exponents. Both variables and exponents must be the same.
But what if the variables are the same, but the exponents are not?
Good question, Lucal. Once the variables and/or the exponents are not the same, these are considered as unlike terms. So even if the variables are the same, once the exponents are different, these are not like terms.
They are unlike terms?
Exactly. Let us look at all these terms on the board. We are going to identify the like terms.
Okay. Let me see if I can remember what we have just discussed. I am seeing terms with only variables and no exponents.
But that doesn't mean that they don't have any exponent. These terms have an exponent of 1.
Oh, so because the exponents of these terms are 1, we don't necessarily have to write it up there? We can leave it as it is?
Exactly so.
Okay, let me start organizing them then. All the terms with just x as their variable are like terms, because they all also have an exponent of 1. So, my first set of like terms are 3x, negative 5x, 7x, negative x.
Very good.
5y, negative 2y, negative 10y, and 4y are also like terms.
Awesome. Let's move on to the other terms. Let's identify all the b terms with the same exponent.
I realize that some of the b have an exponent of 2 and also 3.
Very good. So our like terms would be
3b squared, negative 5b squared, b squared, negative 6b squared, and negative b cubed, negative 2b cubed, 4b cubed, 5b cubed.
Very good, Luckle. Do you now understand how to identify like terms?
Yes, Kelly-isha, I do. And I am sure they also now understand too.
If that's true, guys, give this video a like and I will definitely know for sure. Great. Now that we all understand what like terms are and can identify them, let's take a look at how we simplify algebraic expressions. Let's say we are giving this expression 5x plus 3y minus 2x plus 7 minus y plus 4. Imagine this expression is your backpack after a long school week. Random papers for different subjects, half-eaten snacks, and a bunch of other things you've used throughout the week. Total chaos! When we think of the word simplifying, we think about organisation.
Oh, okay. So I guess I would organize the different papers correctly with their respective subject areas and also put all the other things that are alike together?
Exactly so, Luckle. And I love the fact that you use the phrase, put all the other things that are alike together. When it comes to math, the first rule of simplification is to group our like terms. So, if we take a look back at the expression that we have, the first term that we see is a 5x. 5x is a like term with the negative 2x. So, I would put these two terms together.
Interesting. It's just as we were doing before?
Exactly.
So the next term we have is 3y, and 3y is a like term with the negative y. So we would put these two terms together, right?
Yes, sir. And lastly, we just have the constants, 7 and 4.
We will just put these together, Kelly-isha.
Good. Now we have 5x minus 2x plus 3y minus y plus 7 plus 4. And this is when we group all our like terms together. Now it's time to simplify them. Only like terms can be simplified. So 5x minus 2x will leave us with a what, Luckle?
3x's?
Great job.
Yay. Because 5x's is a positive term, which means that I have 5x's. And negative 2x's is a negative term, which means that I owe, or it's going to be removed or subtracted. Hence, when I subtract 2x's from 5x's, I am left with 3x's.
Very good, Luckle. So, what about the 3y minus y?
It's the same approach. 3y is positive, so that means that we have 3y's, and negative y is the same as negative 1y, which means that I owe 1y and will be subtracted from the 3y's that I have. Hence, I will be left with 2y's.
Boy, you're so smart you could be the Prime Minister one day.
Luckle for Prime Minister, guys.
Psych!
Haha, whatever. Anyways, lastly, we just have the constants, and they are both positive values, so we will just add them together. Hence, 7 plus 4 will be equal to 11.
Awesome, Job. Now, our simplified expression will be 3x plus 2y plus 11.
Done just like magic.
Algebraic sorcery, my brother. Algebraic sorcery.
Let's try another one, Kelly-isha.
Okay, let's consider you're given this expression. 4 plus 3, t plus square minus 6, t plus 3 plus 5, t square. Simplify this expression, Luckle.
No problem. I got this. Guys, let's work this together. Firstly, we should be identifying our like terms. The first term we have is our fourth. This is a constant. The other constant in this expression is the 3. So these two will go together. Moving on. So I'm seeing 4 t terms in this expression. But if I remember correctly, like terms must have the same variables and exponents. So the variables are the same in all. However, the exponents are not the same. 3t and negative 6t will be like terms because the variables are the same and they both have an exponent of 1. Hence, the other like terms would be the t squared and the 5t squared. So, by organization, our expression now will be 4 plus 3 plus 3t minus 6t plus t squared plus 5t squared. That's correct, right, Kelly-isha?
Is he correct, guys? They are saying, yes, you are, and I confirm. So, great job so far.
Good. So it's to get simplifying. 4 plus 3 will be equal to 7. 3t minus 6t. Wait, we are subtracting the larger number from the smaller number? This is possible, Keliesha.
Mathematically? Yes. Look at it this way. We have a positive 3t and a negative 6t, right?
Well, that's what's there, so yeah.
It will make sense soon. Just follow keenly. As I said, we have a positive 3t and a negative 6t. Positive terms mean that it's something that we have, while negative terms mean that it is something that we don't have or we owe it. If you owe somebody money, what's the first thing you should always try to do as you get money?
I guess try to pay them back.
Exactly. Even if it's not everything you have to pay back one time, you should still try to pay back, and whatever is left will be the remainder of what you still owe. It's the same approach when adding and subtracting terms.
Okay, let me try and understand what you are saying. With these two terms that we have here, which is positive 3t and negative 6t, I have 3 t's, but I owe 6 t's. So, with the 3 that I have, I am going to pay it off to reduce the amount that I owe. So that's 6 minus 3, which is 3. So me paying the 3 t's will leave me with no t's, however, I would still be owing 3 t's. And again, owing means the term is negative. So my answer would be a negative 3t.
Correct! Exactly so, Lucal.
Algebraic sorcery indeed.
We could have also done this by a simple rule. Once we are subtracting two terms, we subtract the smaller term from the larger term and keep the sign of the larger term. So, in this case, the two terms are 3t and 6t. 3t, the smaller term, while 6t, the larger term. So we would subtract the 3t from the 6t, which would leave us with 3t. But because the larger term, 6t, has a negative sign, our answer would be a negative 3t.
While I understand the whole having and owing thing, I think that rule is easy to remember. Subtract small from large. Keep the sign of the large. Simple thing.
No problem, Lucal.
Lastly, t squared plus 5t squared will just be equal to 6t squared.
Very good. So our final answer will be
7 minus 3t plus 6t squared.
Yay! Excellent job, Lucal.
Sis, relax. I got this.
Yeah, I know you do, little bro. To all our viewers out there, we have only just started simplifying algebraic expressions. In our next video, we will be learning the distributive law and doing examples where we will be expanding and simplifying algebraic expressions. Don't forget to hit that like button, leave a comment, and let us know if these videos are helping in your math journey. If you're new to the squad, subscribe to continue on this educational journey with us. See you next time, Math Squad.
Bye, guys.